So in the previous course we have talked more about voltage and less about current. We already know that voltage, which is measured in volts, is like a pressure that pushes electrons out of the positive terminal of the battery, lighting up the lightning bulb, and returning back to the negative terminal of the battery. Wait a little bit, pushes out electrons? What are those things? Well, to put it simply, an electron is a negatively charged subatomic particle. It can be either free, which means that it's not attached to any atom, or bound to the nucleus of an atom. Each electron carries 1 unit of negative charge, and if you want to be more exact, a negative charge accounts for 1.602 times 10 to the power of minus 19 coulomb and has a very small mass as compared with that of a neutron or proton. If we take an electrical conductor, current flow results from the movement of electrons from atom to atom individually and from positive to negative electric poles in general. So shortly, current is equal to flow of electrons. So in what is current measured? Well, current is measured in ampere or amps. It expresses the quantity of electrons, sometimes called electrical charge, flowing past a point in a circuit over a given time. A current of 1 ampere means that 1 coulomb of electrons, that's around 6.24 billion electrons, is moving past a single point in a circuit in 1 second. So the calculation is similar to measuring water flow, like how many gallons pass a single point in a pipe in 1 minute, for example. So current can be expressed in amps, milliamps, where 1 milliamp is equal to 0.001 amps, and microamps, where 1 microamp is equal to 0.00001 amps. If you didn't know, ampere comes from the French mathematician called André-Marie Ampère, and I apologize in advance for my French pronunciation. What you have to know is that electrons flow through a conductor, typically a metal wire, usually copper, when two prerequisites of an electric circuit are met. The first one is that the circuit includes an energy source, like a battery for instance, that produces voltage. Without voltage, electrons move randomly and fairly evenly within a wire and current cannot flow. So voltage creates pressure that drives electrons in a single direction. The second one is that the circuit forms a closed conducting loop through which electrons can flow, providing energy to any device connected to the circuit. So a circuit is closed when a switch is turned to the on or closed position. In the previous course we mentioned that voltage can be either AC or DC. Current, just like voltage, can be either AC or DC. When we talk about DC current, we talk about a current that flows only in one direction, right? And when we talk about AC current, we mean a current that flows in a sine wave pattern as shown here, and it reverses direction at regular intervals. You might be curious how to measure current. Well, measuring current can be done using an ammeter, but there is a special device called a multimeter which can measure voltage, current, and many more. So we already know that when we want to measure the voltage across a device, like we did when we measured the voltage of the battery, you have to hook the two legs of the voltmeter in parallel with the component. In case you want to measure current, you need to place the two legs, which in engineering terms is called as probes, in series with the circuit. So you have to break somehow the path and place the two probes in series so that current can flow across the multimeter. It makes sense, right? And most digital multimeters can measure DC or AC current no higher than 10 amps. You might already know this and it's kinda evident, but any component like lamp, motor, heating element that converts electrical energy into some other form of energy like light, rotation, motion, heat uses current. As we said in the previous course, this light bulb in engineering terms is called as load. When additional loads are added to a circuit, the circuit must deliver more current. And the size of conductors, fuses, and the components themselves will determine how much current will flow through the circuit. As a summary, current flows only when voltage provides the necessary pressure to cause electrons to move. Different voltage sources produces different amounts of current. So standard household batteries like AAA, AA, C, and D produce 1.5 volts each, yet larger batteries are capable of delivering greater amounts of current.